Hello, in this video I will show you how we want to create our first API. Our first API is getWallet API, and it will help us retrieve a wallet that we already created, or we will create the wallet with this API. Okay, so now let's check the code. In here we have first file. You see we added services here, and the services here are the new stack that we added. Let's check it out. Inside services, we create a table and we add the partition key as email, and a removal policy we put it to destroy. So every time we destroy this stack, it will delete this DynamoDB. Then we create a lambda handler that will connect to our table. It means it has access to write and read from the table. So this is the lambda that checks if the wallet exists in the database, it will retrieve it, and if the wallet is not exist, it will create it and save it to the database and return us the wallet ID. Here we need to give permission to our lambda function so it can read and write from our table. And in the line 40 we create an API gateway. As you remember from the last video, API gateway is our gateway to the outside world. So everything that wants to call our application will call to the API gateway. Here we try to access the user pool that we create before, and we create an integration and we pass the user pool to it. This integration will create a lambda authorizer that checks every request, and if that request is authorized, then it let it pass. Last step is to create web application firewall, because we need to have some default security measures on our API gateways. Let me explain you the project structure. We have a SRC folder and we have adapters. Adapters in domain-driven design are a concept that helps us connect to the services that we want. We have an API gateway adapter that creates a response that we can send to API gateway. Also, we have a DynamoDB adapter that helps us connect to DynamoDB API. So for example, we have this put item function that we created. This one will create a put item command and send it to DynamoDB API in AWS. And it will help us to create an item inside the table. Now you might think why we are using adapters. Because imagine later you want to change from the DynamoDB to another database. Then you just need to change your adapter and you don't need to change anything in your function code. This kind of structure makes your code to be way more maintainable. Okay, now let's check our handler. Inside our handler we have a function called getWalletInfo from database. What this function does, tries to get the information based on user email from the database. If that exists, it will return it. Then we try to parse the information. If the information exists, the parse will succeed and we put the information inside the database response. But if line 35 throw an error, then database response will be undefined. So after that, we call another function create wallet info in database. Let's go to the definition of this function. As you see here, we call another function called create wallet. Inside create wallet, we create the new wallet with the help of a library called web3, and we return valid ID, private key, and date created. We return the private key from this function, but we never return it to the user because, as I mentioned before, this is a warm wallet. It means the private key will be managed by us, not by the user. Let's go back to getHandler. After this part, database response have a value. It has the valid ID. It might be the old valid ID that created before or the new one that we just created. We get the valid ID from database response and we return it to the user. We have an infra folder also. Inside infra folder we have a folder called common. Here we try to extract away the logic that we need to use in AWS CDK. For example, here I create a function called create API gateway and it will create a REST API. So every time we want to create an API gateway from now on, we just call create API gateway. For DynamoDB, I create a function to create a DynamoDB table. For Lambda and AWS Web Application Firewall, the same. As you see here, the AWS WAF that we are creating has a lot of logic, but we don't need to write all of that in our stack file. It makes our code more maintainable. At the last part, we have config. Inside the config, we have the application config when we want to create the stack. The only thing you need to change here is Cognito user pool ID, because you need Cognito user pool ID from your AWS dashboard. Let me show you how you can get it. Here I am in my AWS dashboard. If you click on Amazon Cognito user pools and crypto wallet user pool, this is the name of the user pool we create in the older videos. If you follow along, you should see this user pool here. If you click on it, you see a value called user pool ID. You can just copy it and then paste it here. Inside share folder, we have models that we need to use for our domain. We have domain transfer objects and we have entities. And for now we have only valid schema as an entity. Then we have some logics for error handling and also logging. Some places that I think it's important, I write the test for everything, so you can check it yourself. You can find the link of this repo inside the description of the video. To deploy the stack, you just need to run this script, npx cdk deploy services stack. After you deploy the stack, it's time for us to test everything working fine. For testing purposes, we use Postman. If you don't know anything still about Postman, it's an application that we use to test our REST API or Socket API. It has a lot of features that we can use, but now we just want to use REST API testing. So let's see how we want to use it. In here, I have my Postman API. Let's see how we can test our solution. Click on CloudFormation and then go to stacks, and here click on services stack. And if you check outputs, you should be able to see this export after you deployed successfully services stack. You copy it and go to Postman, paste it here, and add get wallet at the end. You also need the token. I will teach you how you can get the token from AWS Amplify API in your React Native app. To be able to get the token from AWS Amplify, we need to a little change our code for the front end. Inside the front end, as you remember, we have only one button in the main page that signed out the user. Here I added a new button and I name it Get Access Token. And this button will call a function called getToken. And inside getToken, we fetch auth sessions from AWS Amplify, and we try to log the route token. Route token is the JWT token that I talked to you about in my last video. Let's see how it will work. Okay, now you see that we have the QR code here ready. Let me scan it. As you see, it goes to the Expo app and it's try to build the app. Because I already logged in the app, I have two buttons here. The second button is the button that we just created and it called Get Access Token. Let's click on it. When I click on it, immediately you see the JW token here. The only thing you need to do is to copy it, go to Postman, go to Authorization, and paste your token here. Now the new token is in place and we should be able to call the Get Wallet API. Let's try it. As you see here, we already get the message wallet ID, and the wallet ID inside data is this one. Now our API is working, so we have successfully created a blockchain wallet inside our database. We send back the wallet ID to the client and we keep the private key inside our database. See you in the next videos.